Hello James, hello Chris, hello Vidak. Let me present you the tool I am going to use to finish Hardstack. It's a digital logic emulator made to work with. It embeds all the TTL. It's in French here, but you will see that. So you see, it embeds many useful things. You can have some displays of several kinds, 7-segment, even LED matrix. This is a demo program which is using LED matrix. You have all kinds of memories, GK, D flip-flops, and you have the whole 74LSxxx libraries. They are all there, so it's perfect. You have also all the kind of memories I am using, most of them at least, for Hardstack. So it already embeds everything. There is nothing hard to configure. The schematic editor is very easy to use. It's a drag and drop click. Let me switch to, I want to see buses length. Oh, they are not displayed here, but okay. So this is a Van Neumann CPU demo with a ROM, with a program. It outputs stuff on the matrix LED segment, and let me play a run, and you're gonna see, up, here we are. So here the clock is at full speed, so what you see animated on the screen is not really relevant. So it goes in, it reads its internal program from a ROM, which is not displayed here. It is embedded here in this block. This is a hierarchical editor, meaning that these blocks have a content made of logic gate and so on. So it's the top of the hierarchy, and you can include breakpoints. You can display traces like on an oscilloscope. So it's the perfect tool to develop our different FSMs. It has an embedded FSM editor. Let me show you. Synthesis. Where is it? Simulation. Yeah, finite state. So you see, you can ask it to, you can create, I am going to open an already made demo FSM. Let's choose traffic light implemented in the way of Medvedev, or yeah, for example. Medvedev FSM open. So here is a state diagram. From here you can generate the transition table with the equations, and from here you can generate a circuit, and here it is, and you can immediately test it. It's a number, it's the numbers of the states, and here you have an animation with the different this is a demo of a traffic light. So it's a very easy to use simulator that allows to construct all kind of digital engines. It's very convenient, and see on this demo with this embedded processor, it's really great. You can make it run with a step-by-step. This is what I'm doing. So you can insert breakpoints to have the flow executing just a given number of clock cycles to perform a given task, and then stop and see the values of the different wires. So it's really a great thing. This is exactly what I was looking for to develop Hardstack. This is a custom component. It has a special shape, but if I open it, now I have to stop the simulation. Open. here is its content. So you see, and these boxes are also have a content. So it's a hierarchical, it's perfect for what we need to do. It's very well represented on the screen. It's the perfect tool to test our thing. With that, we can construct all the different engines of ArtStack. We can simulate them, test them, and ensure it's working. They are working correctly. Then we just have to make the final schematic with KiCad, which will be a copy paste. It can export directly its schematics to VHDL to test on some FPGA boards, because the emulation here is limited by speed. The clock cannot go higher than 50 kilohertz, but it's already enough to do all what we need to do. I mean, 50 kilohertz. I don't know how many cycles are going to be needed to test the anonymous ID generator. Maybe I would say 2,000 or 3,000, maximum 10,000 cycles. So it's perfect. This is what I was looking for. What is good is that it is very easy to play with it, to edit stuff, to change stuff. That's the perfect tool for the work we have to do. And thanks to that, we are going to speed up the development. We are going to be able to easily make some optimizations on the architecture and fine-tune everything. And we are going to be able to emulate ArtStack at 100%. I insist on that. This is very important. So you see, it was a matter of finding the right tools, testing them, to evaluate them. What I appreciate is that it has many input outputs. Let me add a segment thing here. I want to have a look of the values on this wire. This is here. It's a 4-bit bus. So this is a next hexadecimal 7-segment display. So let me cable the bus here up. I cable it to that one. Here I put a constant. This is for the dot. The dot will be displayed. And then I press run, and look. It shows the X value, the hexadecimal value of this 4-bit bus in real time on the display. So debugging is very easy with this tool. We can have it running in a step-by-step mode, or inserting breakpoints everywhere we need it. So it is the perfect tool to debug our engines. With that, we are gods. We are the gods. And all these embedded little things like to display values and so on, it's so handy. So I am going to start implementing the anonymous ID generator with this tool. I just need to first do a component, which is not in the library. It's a double port static RAM. There is one, but it is not as we need it to be. So I have to first do a custom component, exactly like all the things displayed here. And then I'm ready to start the schematic of the engine. Here it is. So it's called Digital, and from Mr. I will give you the link to download the program so that you can play and comment the work we do. But with that, we can finish the anonymous ID generator in 2 weeks. And it's from far the hardest part, the hardest finished state machine of ArtStack. All the other state machines are much easier. And I haven't shown you perfectly all what can be done with the finished state machine generator with the state editor, but it's great. We can do everything we want in a very academic and scientific way, using the right methodology to create these FSMs, and it can synthesize the logic with either GK flip-flop, D flip-flop, or just non-gates. You choose what kind of synthesis you want. It saves a lot of time. It manages Carnot table too, so this is the perfect tool. Thank you for your attention.